and welcome to another video on Thevenin's theorem. In this problem, we're required to find the Thevenin equivalent of this circuit, and this circuit is quite special because it has a dependent power source. And in order to find the Thevenin equivalent, we need the Thevenin voltage and the Thevenin resistance. So now to do that, first thing we do is we detach the resistors from the terminals, which has already been done for us. The next thing is we find the currents and voltages in the circuit, and we can easily do that for this circuit by using nodal analysis. So we have about 3 reference nodes. This is node 1, node 2, and node 3. So we can make this our reference node. Make this our reference node, then make this node 1 and make this one node 2. We can use node analysis to find the node voltages in the circuit, and that will turn out like this. We'll say that at node 1, so okay, we have node 1 is 24 volts. You can just see it because you have this power source connected between node 1 and ground. So we say that V1 equals 24 volts. That was easy. We can then proceed to node 2. So at node 2, we write the KCL equation at node 2. So we have V2 minus V1 divided by 2. And we call that V1 is 24, so V2 minus 24 divided by 2, then plus 4, then plus 3ix, then plus V2 over 8. Now, V2 over 8 is also the same thing as Ix because that is the current flowing through the 8 ohm resistor. So we say we should probably write it here that V2 Ix is equal to V2 over 8. So we can come and substitute that here. We equate all of this to 0. This is the KCL equation. We can come back and substitute that here, and we will have it that V2 minus 24 over 2 plus 4 plus 3V2 over 8 plus V2 over 8 equals 0. Then if we add all this together, then we will have V2 minus 24 over 2 plus 4 plus 4V2 over 8 equals 0. And then multiply through by 16. If we multiply through by 16, we would have 8V2 minus 16 192 plus 16 times 4, that would be 64 plus 8V2 all equals 0. If we solve that equation, we arrive at V2 equaling 8 volts. So now we know that V2 is equals to 8 volts. Then the next thing we just want to do is connect a virtual power source here, and that will be your VTH. And if that is your VTH, we know that Ix is equals to 1 ampere. That is 8 divided by 8. So we can write a KVL equation here, and we know that VTH minus 8Ix equals 0. So we know that VTH equals 8 volts. Now the next thing we want to find is the Thevenin resistance, RTH, and finding the Thevenin resistance is kind of tricky when you have a dependent power source in your circuit. So what you're going to do is you're going to connect a 1 volt power source across the circuit. Then you're going to look at the effect of that power source on the circuit, and you're going to use that to determine your Thevenin resistance. Now this is the kind of circuit you're going to be using to determine the value of RTH. What we've done here in essence is that we've turned on the independent power sources. For the voltage source, we replaced it with a short circuit, and for the current source we opened it up. And then the next thing you're just going to do is you're going to connect a power source across here, preferably a 1 volt power source. Then that means that RTH would be equals to 1 over I, where I is the current that comes through here. So what we want to find here is the value of I, and recall that Ix is the current flowing through the Thevenin resistor. Now according to Kirchhoff's current laws, we know that I would be equals to Ix plus, let's call this current I1, plus I1 plus 3Ix, right? Then we know that since this is connected directly across the 1 volt power source, then we know that Ix is equals to 1 over 8. Okay, then we also know that since this is connected across the 1 volt, this is also connected across the 1 volt power source, I1 is equals to 1 over 2, that is voltage over resistance. Then we can say that I is equals to, this will be 4Ix, so 4 over 8 plus 1 over 2, and that would be equals to 1. So current I is 1 ampere, then RTH would be equals to 1 over 1, which is 1 ohm. Then the Thevenin equivalent circuit will look somehow like this, and we have 8 volts here, and then we would have 1 ohm here, and this is the Thevenin equivalent circuit. Thank you for watching. Don't forget to hit the like button and subscribe. See you next time. Bye.